In this video, we're going to solve a system of equations, and this is a nonlinear system. Notice the first equation has degree 2, and if you multiply the second one by x, it also becomes a second degree expression. So normally when we solve a system of nonlinear equations, you normally use either a combination of elimination and substitution. So what we'll do here is we'll multiply the second equation by x to clear the fractions. It'll be x times x over here will give me an x squared. 1 multiplied by x is x, so this is plus x here. And then on the right side, the x cancels out. So this will give me a 2 minus y. Now at this point, you should know that when you check any equation or system of equations, you eliminate or reject any values that give you a 0 in the denominator. So here notice the original equation here, even though I multiplied it by x, you're working with the original ones. X cannot be 0. So you get a possible answer of x equal to 0, you have to reject it. So now what I'll do here, I'm going to work with this equation, the first one, and then the one that I simplified by multiplying by x. And I'm going to multiply through the second equation by -1 and add it to the first. So it'll be a negative x squared here and an x squared, that'll cancel. Be a minus x and an x, that'll cancel. So that'll leave me with a y squared on the left side. And then on the right side we have a minus 1 times a plus minus y. A plus y and a y is 2y. And then a minus 2 and a 2 cancels. So I get this equation right here. So I'm going to solve this one by factoring. Y squared. Bring the 2y over. That's the same thing as adding a minus 2y to both sides. So I get y squared minus 2y is equal to 0. It's a quadratic. Factor this out. Factor y out. Get y times y minus 2 is equal to 0. So that means that one of these factors, either one of these factors could be 0, they both could be 0. So we set each factor equal to 0. So that gives me y equal to 0. And y minus 2 would be 0 when y is 2. So we're solving this system, and basically what we're doing is finding the points of intersection where the system of equations intersect. So they intersect with y equals 0 and y equal 2. So now we need the values of x. So let's replace the y by 0. And I'm going to use this format here. So if y is equal to 0, notice that gives me x squared plus x is equal to 2. Take the 2 over, and I get x squared plus x minus 2 equal to 0. Another quadratic, so this can be factored into x plus 2. So it's x plus 2, one factor, and x minus 1 is another factor. So one side is 0, so x plus 2 can be 0, of course, when x is negative 2. And x minus 1 can be 0 when x is equal to 1. So we know that the equations, the graph of these equations intersect at where y is equal to 0 and y is equal to 2. So we simply need the x component of those points. So when y is equal to 0, x can be negative 2 or 1. So one ordered pair solution would be negative 2 and 0. And the other one would be 1 and 0. So that's what we get when y is equal to 0. Now what happens when y is equal to 2? So let's come back to this one then again and put a 2 where the y is. That would give me 2 minus 2 would be 0. So I would get, for that, I get the equation x squared plus x. And 2 minus 2 is 0, so this would be 0. And then this would factor into x times, factor out an x there, and x plus 1. So from this quadratic equation then we get that x of course can be 0. Then x plus 1 would be 0 when x is negative 1. So another solution pair here when y is equal to 2, because that's what we substituted here to get this equation here. When y is equal to 2, x can be negative 1 or x can be 0. But remember we said that that has to be rejected because if you try to check it, put a 0 in this equation here, you get a 0 in the denominator. So that's undefined. So the complete solution then, where the points intersect, or where the graphs intersect, I should say, are at -2, 0, 1, 0, and -1, 2, which of course represents the solution to this nonlinear system. Thanks for watching. We'll see you next time.